Hey YouTube, Do-It-Yourself Junkie 369, and today I'm going to be looking into something I've kind of wondered since I've started this project, is how loud is it and how disturbing is it for other people? Like, my daughter's bedroom is kind of over the garage a little bit. Am I keeping her up at night by being down here riveting? And should you be wearing hearing protection? Just based on my personal experience, I'm going to say definitely while riveting, yes you should. Probably should use it during the drill, but we'll see because I have a sound meter. So I'm going to take a couple sound readings. This sound meter goes up to 130 dB. So if I get an anomalous reading, it'll say something like OU for over. And then it can do a max sound hold, so I will display that. And I don't want vibrations from the table while I'm riveting to set it off. So we're going to set it about 6 feet away over here on the toolbox. Now, sound is not linear, but it does have a certain amount of drop for every so many feet. And I'll put that at the bottom of the screen because I don't happen to remember it offhand. But first up, we'll do riveting, and then as I empty out my air compressor, hopefully it just will decide to kick on and we can get some noise levels for that. So that was 123.8 dB. That's quite loud. And at the bottom of the screen here, we'll have the recommended OSHA exposure to sound. I would definitely, and that's at 6 feet. At my ear, it calculates out to be this loud. And at that level, I would definitely recommend using hearing protection. Let's try to drill next. And for this one, I'll hold the sound meter next to my ear, since I'm just going to run the drill over here. So that was 96 dB. Although I'm only running 30 psi through the drill, let's see if I crank it up to its operating range if we'll get a higher reading. Now I have it set at 60 psi, which is more of a normal range for operating a drill. So at the ear, 107 dB. And just to give you an idea of how much that decreases over distance, we'll put the drill at 6 feet and run it again. So 6 feet dropped it to 105.4 dB. Which, if we do the math, we'll see if that agrees. Now, I'll stick the meter in my daughter's, or in the kitchen, just on the other side of the garage door, and see what the max reading is. So 85.3 decibels just being on the other side of the garage door. Now the washing machine was running in there, and that made the area that I set the microphone down about 45 decibels, to give you an idea of what the background noise level was like in the house. I think putting it upstairs in my daughter's room will probably get us our lowest reading. Let's go check it out. Okay, that said 63.8. It was actually 52 point something up in my daughter's room. All that max hold that you're seeing was me walking through the house. My flip-flops on the tile made more noise than what registered in my daughter's bedroom when I drove that rivet. Next, I plan to stick it outside the garage door, see how much noise is making it through there. I do live near an airport. There's cars driving past, and I have a feeling those are probably going to result in my max noise reading if I'm not careful, rather than me driving a rivet. But we'll see. Okay, so 103.8 is what I registered outside. To give you some concept of how loud that is, the background noise outside is 52 dB. There's a really noisy bird chirping and some traffic down on the main road not driving directly by my house resulted in that reading. That being said, 103 isn't double the noise of 52, because decibels work on a logarithmic scale. So every 3 dB is about double the noise. So all we have left to do now is capture how loud the air compressor is, and we can kind of work out mathematically how loud that will be in each of the locations based on how loud it is compared to the riveting. And then also I can look at the distance of my neighbor's house and mathematically figure out how loud the noise level is to them, and whether or not it just shows up as kind of background noise, about that 45 to 52 dB. Now we'll try to get a reading of the air compressor over here in my work area. Okay, so there we have our different noise levels. And as part of that, I did an at the ear reading of the air drill, and then I did, which was about 2 feet from the drill. So you got to think it's not 0. And then I did the air drill at what I called 5 feet. That ended up being actually 4 feet after I got out a tape measure and measured it. And then I did the same thing, but I calculated that expected volume level. And in that, the calculation is 4.5 decibel lower than what the actual reading was. And that's quite a bit. That's a little bit of over double the sound level. Not the sound level we can perceive, that's still like around 10 dB, but actual doubling is about 3.1 because it's on a logarithmic scale. My theory is part of that is due to when I took the sound reading at the ear, I had the microphone pointed straight up, which is normally how I've seen readings taken. When I had it at 4 feet, it was laying on its side and pointed at the drill. And so I think that's where the difference is coming in. So anything I've calculated versus what actually is being read, we can assume there's probably a 3 decibel error. which is a lot, but the data that I have will still show that pretty much you need to wear hearing protection whenever you're riveting, drilling, the air compressor's running. All of those are going to be quite a bit above 85 dB. 85 dB is the OSHA cutoff for 8 hours of exposure. Now granted, none of this is really 8 hours of exposure, but as the sound levels double, each time they double, the exposure limits half, what that means is at 88 dB, you're now down to 4 hours of exposure. At 91 dB, 2 hours of exposure, which 91 is the air compressor running. If you're working an 8-hour day in here on the airplane, it's really easy to hit 2 hours of the air compressor running. 94 dB, that's roughly an hour of exposure. 97 dB, we're down to half an hour. That's about what the air drill was registering at when it was running at 30 psi. When you're running at closer to 60 to 80 psi where it should be run, it's much, much higher. 100 dB, you're looking at half an hour of exposure. And you could easily, that's not even to the range that the air drill was at, and you can easily hit that half hour. Really, with the air drill, you're looking at maybe 7 minutes of exposure. With riveting, you're closing in on instantaneous hearing loss based on one exposure. And this is the person running the rivet gun, not the person holding the bucking bar, although both of them are probably close to being in that range. Person holding it is at roughly 129.8 dB. That was calculated. At 4 feet, it dropped to 121.8 dB, which is the actual reading that it attained. But even that is still really too loud to be working without hearing protection. You're looking at under 15 minutes of exposure as your threshold for hearing damage, and it's really easy to hit that. The good news in all this is everything up in my daughter's room, calculated or actually taken a reading, was under 52 decibels, about 52 and a half. That's almost the same background noise in the whole house, especially like, let's say I'm in the living room and the dishwasher's running, that's the background noise that we're getting. So I don't think, other than the impulse of it, there's nothing really that she should be waking her up. Drilling's even lower, and then the air compressor could probably barely register. And I know I've accidentally not turned off the air compressor and it's kicked on in the middle of the night and I can barely hear it. In the kitchen, the only thing that's really closing in on a dangerous level is the riveting, and it's barely above 85 decibel. So it's probably not really anything to worry about, especially you're going to have a hard time hitting that 8 hours total of exposure. Unless you're just riveting non-stop, which on this type of project, you're not going to be doing that. And in case you're wondering, the second column that lists exposure limits, for everything that's colored in red, that is stuff that it's above that 85 dB, and you're going to have some sort of exposure limit, and those are listed in minutes. So riveting, you're looking at 16 minutes. Drilling, you're just a little bit over an hour and 5 minutes. And then, as I said, the air compressor, 120 minutes or roughly 2 hours. So I went ahead and calculated those out so you could see what kind of drill you're using and what kind of rivet gun you're using. Probably has some sort of impact on that noise level, so it won't be the same for everybody, but it'll give you an idea. Anything that's colored in green, that's basically background noise level, around 50 decibels or lower to where you're not even going to notice it. So I have two neighbors that I have to worry about. The closer is roughly 76.5 feet. That's to their property line, not their house. So if they were standing on our property line, wondering what was going on, that would be the noise level you get. To their house, it's even less decibels because it reduces over distance. And then to their inside their house, they're probably not even going to hear it, quite honestly, with the levels that I was picking up. When I'm riveting, it's definitely something they're going to notice at around 66, 65 decibels. But that's if they're standing on their property line. That's going to drop a little bit where they're normally going to be outside in their yard. With the background noise going on, especially cars going by, they might realize something's going on, especially just because it's that impulse noise. Drilling an air compressor running, they probably aren't even going to really notice it, especially over cars and everything else that are producing about 50 decibels. And that's just background traffic. That's not even a car driving by their house. So I was a little bit worried, and I know a lot of people out there ask, how loud is it? How much is it going to bother my neighbors? This should give you a rough idea on that. If you have neighbors that are a reasonable distance away, or even kind of a tight neighborhood, like subdivision, they might realize something's going on, but they should not really have a noise complaint. People's music is usually louder than the readings that I was getting. If you're in an apartment, that's going to be a little bit harder because they will hear a definite noise, and depending on what time of day you're doing it, it might irritate them. I mean, riveting was 52.5, and granted, I say that's kind of background noise, but because of that sharp impulse, it could bother them. It could be something that you realize is happening, especially if they're a light sleeper. Biggest takeaway is I should be wearing hearing protection whenever I'm out here working on the plane. You should too. It does no good to build an aircraft and then you can't use it because you can't hear the air traffic controller calling you, or a stall warning horn, or something else because you've lost your hearing during the build process. I'm going to make more of an effort to wear hearing protection while working. Another thing that I didn't cover really, I covered it a little bit in my injury video about hurting my hand, that working with taps and brittle metal and stuff, I should be wearing eye protection. These glasses really don't qualify. You can get prescription lenses that do provide eye protection, but I don't think this has enough coverage really. And other things like drilling, where you have shavings coming off, I should be wearing it. I did notice while there was a lot of drilling on this for the J stiffeners, and during that the drill was getting to me, like it was a lot of exposure to that level of sound, and I should have had hearing protection on. So just wanted to put that out there. Also give you an idea of how loud it is so you can figure out if you're going to be bothering your neighbors by doing this. I did not do the C-frame. Really, you can just say that is as loud as using the rivet gun, even though it's a slightly different noise and different tempo of impulse. Hopefully you found this video helpful. You liked it. If so, give it a thumbs up. Think about subscribing, and thanks for watching, and see you in the next video.